Excited to be here at Cornell Tech because I am graduate of Technion, if some of you may know, and Technion and Cornell at the time, I remember there was the talk about starting it. I was very excited, so first time being here, very excited. Yeah, we are Team SpaceComputer, and we teamed up with a bunch of very high-quality nerds. So Professor Dalia Malki from UC Santa Barbara has been with us since before we started. Filip, my co-founder, who's PhD in cybersecurity and distributed systems from TUM. Yang Guo, who's a hacker, open source, and for me, I'm background in physics, semiconductors, and venture in crypto. So why the heck are we building a blockchain in space, and how did we get to consider this even? So if we kind of reflect back on the breakthroughs of crypto, the Bitcoin network, which was the first thing to actually emerge as the thing that opened the field in a way, was supposed to be a distributed compute platform for only one application, the peer-to-peer payment system, eCash. Ended up more like a digital gold than payment, but nevertheless opened the field. Then came Ethereum that basically expanded it to general purpose computing, so a Turing complete environment distributed computer for general purpose application, the world computer. Now, we basically see that the space frontier is re-accelerating, and we see that more compute is migrating to space, more applications are imaginable. So we see that the secure environment of space becomes alternative to what we can guarantee here, and therefore the space computer. So we see a steady decline in price of the launch per kilogram. So there is a projection, Starship, which some of you may know from the SpaceX, is projected to have 400 times more payload space than current Falcon 9 missions and other alternatives to Starships. All that would lead in the next 5 to 10 years to about $10 to $100 per kilograms. It's like less than a gas cost for some random NFT collection that you collect over the weekend. So with this, we basically see that more and more applications that until now were only for state-level actors imaginable are possible. So we use the physical isolation of space to provide high security guarantees for secure computing, and that's SpaceComputer. And I'll hand it over to Filip to give us a deeper dive.
Great, thanks, Daniel. So the state where we are currently at is, of course, we don't have the full topology fleshed out yet because it takes some time to build it up. So we already have access to a single satellite. But already this setting enables us and provides us a lot of capabilities we can do to build our future of the space computer we envision. So starting with the status where we are, we want to provide already as of now the interaction to users that can play around and see what are the use cases the space computer can unlock. For that, we have also built our own terminal called OrbitPort that is interacting on the user's behalf with the infrastructure itself, that is providing the secure features provided by the Space TE and many others running in the space. The vision we envision for the future of space computer is to build on top of already existing solutions when it comes to, for example, L2 solutions that we know from Ethereum ecosystem. And the reason for that is like we will be for a long time communication and computation constraint in the space environment and have to accommodate for the demands of the users. So for that we aim to provide a very secure and robust L1 with on-Earth components that are handling and providing the off-chain computation capabilities on Earth, and users are already, as of now, used to interact with, and later on store all of the data on the robust L1. I already briefly mentioned it, but the aspect of the interaction is built around the terminal called OrbitPort, where already as of now we are opening a public beta preview where people can play around and get access to the true random number generator from space, which allows you to build and initialize, for example, your AI agents, be used in cryptographic primitives and many others, and build and be creative when it comes to your solutions that you are interested in. This is something that we plan to expand to accommodate for future use cases provided by the space computer itself, already either on the single satellite, but also in the future on the multi-satellite setting as well. We already have a first demo, as we have heard today in the sessions, what is very important in the Web3 space is gambling. We are not trying to shy away from that and see an interesting applications in gaming that are relying on the randomness from space. So you as a user can actually launch and interact and collect the randomness from space as a part of your game. That will, for example, determine the rarity of your item you are able to get. You will get an information about the randomness coming from space that will be signed by the respective satellite that is provided to you on your front end. And you can, based on that, determine the rarity of your item. So this is just a use case that we already aim to support as of now, provide it directly from SpaceComputer to the users. But you can imagine the landscape is broad, and on that part I will hand over to Daniel, who will dive us through additional type of use cases you want to build on.
Yeah, so what we see basically with OrbitPort as a terminal for space compute is that the first application, Cosmic True Random Number Generation, is enabling all of those use cases such as gambling, and I'll touch on a couple more. But then essentially, as we are enabling more applications, MPC, for example, generating proofs, ultimately, the result of this is to create a standard for space-native economy. So the applications that we're already working on with a few POC partners are in AI generative art. So let's think about traits that are changing your NFT collection or anything else. AI agents that have variance between their traits based on the randomness seed, and programmable cryptography are things that are just in the beginning of our work. So what we're doing now is enabling the CTRNG with a few partners. And if anyone here is interested in this application or the MPC wallets, proofs that are generated on the satellites, please come talk to us afterwards. And ultimately, working towards having a production-ready single satellite, and then eventually launching a network of space TE nodes that will be the kind of environment for the L1 in space. And with that, you can check our demo through the QR code or connect to us on X or join our Telegram group. Thank you.